Hello folks, welcome to this series of AWS services. We are discussing networking part of AWS. In the last video we talked about VPC, we get an introduction about the virtual private cloud, and in this video we are going to talk about the subnets. So what is a subnet? Subnet is coming from the word subnetwork. So as the name suggests, these are the smaller part of your VPC. So these are the group of resources within the virtual network that can be grouped together and on which similar kind of routing policies and access control mechanisms can be applied. So remember in the last video we talked about the group of developers, group of QAs and group of admins. Now there will be some EC2 instances associated with these groups. So EC2 instances or any other resource that belongs to say developer group can be put in one subnet, and the AWS resources that belongs to say QA group, they can be put in a different subnet, and so on and so forth. All these subnetworks can coexist within the same VPC, and a separate set of routes and access control mechanism can be associated with one subnet. Now another aspect of subnetworks is that subnetworks are restricted within an availability zone. Remember when we started this series, we talked about the global infrastructure, and there we talked about region and availability zones. Availability zone loosely tells you about individual data centers. So subnet has to be restricted within one availability zone. And this is why each region has one default VPC but has got multiple subnetworks, because for each availability zone you need to have at least one subnet. Having said that, within one availability zone you can create multiple subnets. So like VPC, subnets are also identified by its CIDR block. So the way you associate a particular IP address range with a VPC, the same way we define an IP address range, also called CIDR block, with each subnet. The CIDR block of the subnet has to be subset of the VPC in which it is getting created. Also, the CIDR block of two subnets cannot overlap. What I mean by this is, when you assign CIDR blocks to various subnets, you need to make sure that there should not be an IP address which can belong to both the subnets or more than one subnet. If there is an overlap of these CIDR blocks, these IP address ranges within your VPC, then VPC would not let you create those subnets. So you define CIDR block of subnets based on how many resources you want to create within a subnet. So if you want to create a large subnet, then your subnet mask would be smaller. If you want to create a small subnet, then the mask in your CIDR block would be larger. So let's go and see the existing subnet. So like default VPC, AWS also provides you default subnet in each availability zone, and these subnets will belong to the default VPC. So let's go and check it out in our AWS console. So this is the VPC, only one VPC we have. The CIDR block of the VPC is 172.31.0.0/16. Remember the CIDR block. And then let's go and see the subnets. So here we see that we have got three default subnets available. There are three subnets because in this particular region, Oregon, you have got three different availability zones. And here you can see the availability zone, US West 2A, 2B, and 2C. All these subnets belong to this VPC. Each subnet would have a subnet ID to identify the subnet. Then each subnet will also have a CIDR block associated with this. And this is very important. Now, if you see the structure of these CIDR blocks, all these CIDR blocks are the subset of the CIDR block of the VPC. How do we know that? By looking at the starting 16 bits of this CIDR block. All of these start with 172.31. The CIDR block of our VPC was 172.31.0.0/16, which means the starting 16 bits has to be constant, and that we can see here in all the subnets. Now here subnet mask for each of them is 20, which basically tells that the starting 20 bit of this CIDR block has to be constant, and the rest 12 bit of each subnet can vary, which means the EC2 instances or any other resource that will be created within the subnet will get a private IP, and the starting 20 bit of that IP address would be same as this particular address in this subnet. And same thing will apply to other subnets. So rest 12 bits can change, which means the number of IP addresses that can exist within this subnet would theoretically be 2 to the power 12, which comes out to be 4096. But within each subnet, 5 IP addresses are reserved by AWS. So the total effective number of IPv4 addresses within this kind of subnet would be 2 to the power 12 minus 5, which comes out to be 4091. So within each subnet, this much IPv4 addresses can be assigned. So what are those 5 addresses which are reserved by AWS in each subnet? So suppose the CIDR block of your instance is something like 10.0.0.0/24, then in that subnet, 10.0.0.0.0 is assigned for network address. .1 is assigned by AWS for the VPC router that is managed by AWS. .2 is reserved by the DNS server. .2 is reserved for the DNS server. .3 is reserved by AWS for any future use. And the last address in the each subnet, .255 normally, is reserved for network broadcast address. Now broadcasting is though not supported by AWS, but it still reserves it. So basically the first 4 IP address of a subnet and the last IP address of the subnet is reserved by AWS. You cannot use them to assign it to any resource such as EC2 instance. So now also remember that whenever you create resources like say EC2 instance or a database, you create them within a subnet. So if you remember while launching EC2 instance, you also have to select the subnet. And that in a sense also dictates that in which availability zone, that is in which data center you are creating your resource. Because subnet are always restricted within an availability zone, and the availability zone is nothing but a data center. Other feature of the subnets can be seen from the summary page. So this is the subnet ID. Then you have got CIDR. The state is available. The VPC it belongs to is given here. This belongs to the availability zone that is mentioned here. And then it is associated with a route table as well as a network ACL. So the subnet is basically associated to this route table, which will mean that any resource within the subnet will follow the routes which are defined in this particular route table. And also, since it is associated with this network ACL, so any traffic to and from this subnet will be guided by access control list defined by this network ACL control list. So any traffic, the rules of the traffic specifying protocol and port numbers are written inside this network access control list. So other than this, what are the types of subnet? Now subnets are chiefly divided into 2 types. One is called public subnet, another is called private subnet. So public subnets are those subnets where you've got resources which can access internet and internet users can access them, which means every resource would normally have a public IP address. Now since we are talking about IP addresses, please keep in mind that when we talk about this CIDR block and IP address ranges, we are always talking about the private IP address. We do not have any control over the public IP address that gets assigned to a particular resource. We can only dictate that which resource will get a public IP and which resource would not get a public IP. So remember, while launching the EC2 instance, we had a field called auto assign public IP. That setting used to come from the subnet. And this is where you can see auto assign public IP. So if you are creating a public subnet, then first of all, the resources in this subnet should have a public IP. And the second thing is that in the associated route table, there should be a route towards the internet gateway so that traffic with the internet can be established. As opposed to public subnets, private subnets do not have a public IP. So they will just have a private IP address. Using these private IP addresses, the servers within the VPC can connect to these private instances which are part of private subnets, but any outsider beyond that VPC cannot access those instances directly because those instances will not even have a public IP. Having said that, these private instances can still interact with the internet, say download something from the internet by using a concept called NAT gateway. And we will talk about that further in the upcoming videos. So what is the utility of the public subnet and private subnet? Normally public subnets we will put for servers like web server, the servers which needs to be accessed from everyone. And private instances will be those instances that are working in the back end. These servers have sensitive information, so we don't want to expose them with public. So in an enterprise, you will be working with public instances and public subnets as well as private instances which are kept in private subnet. So to further explore subnet, we can look at the route table associated with this. And here we go. We can see in this route table, we have got two routes and one of the routes is pointing to the internet gateway. So this is a public subnet because it has got a route which is pointing to the internet gateway. We'll talk about route tables in detail in the subsequent videos, but just be familiar with the structure of this route table. Let's go to the network ACL, and here also you get that there are various rules in the network access control list, and these rules will guide the traffic going out from the subnet and going into the subnet. So inbound rules will dictate that what kind of traffic is allowed to go inside the subnet, and outbound rules define what kind of traffic and through which port and protocol it is allowed to go outside the system, outside the subnet. So similar to VPC flow logs, we have also got subnet flow logs, which will help you monitor, troubleshoot, and secure your network in a better way. Then we have got tags, which are nothing but labels associated with each subnet. So any key value pair you can put here, which will be now label over this particular subnet. So that's all we have in the subnet. We'll talk about subnet association with the route tables and network access control list in the subsequent videos. So hope you enjoyed it. Keep seeing the other videos of networking to understand the full concept and the interrelation between various VPC resources. So see you in the next video. Thank you for watching.